Assalamualaikum and a very good day to Dr. Siti Hidayah Muhammad Saleh and Dr. Azni Shahari. I'm Nohida binti Baharudin. We are from P37M21. Will be presenting a study entitled Numerical Solution of the Depth of Submerged Ball in a Reverse Osmosis Water System by using Bisection Method, Newton-Raphson Method and Seeker Method. Our group was supervised by Madam Rosha Muhammad.
Assalamualaikum. My name is Nur Ika Shafika binti Jaslan.
Hi, my name is Nur Shazrina binti Harun.
For our presentation outline, we will cover 12 parts. Let's start with the first part. For abstract, the purpose of this study is to determine the depth of submerged ball in a reverse osmosis water system using bisection method, Newton-Raphson method, and Seeker method. We will evaluate Archimedes' principal equation using these three methods. This issue will show all the proving from the equation by calculate each method and compare which method gives the least absolute error. Result has shown that the least error is Newton-Raphson method. Therefore, the appropriate method to determine the depth of submerged ball in reverse osmosis water system is by applying Newton-Raphson method.
The reason why we're using reverse osmosis in this research because reverse osmosis is better than forward osmosis. A well-known issue with reverse osmosis membrane is fouling and scaling, where organic and chemical residue, oxidants and scaling ions build up on the membrane surface. This reduces the effectiveness of the membrane and requires frequent maintenance and backwashing. Ideally, a reverse osmosis membrane should only handle water and pure sub, but with the complex composition of industrial wastewater effluent, this is rarely the case. To calculate the depth of submerged ball, we're using a general method of numerical analysis, which is bisection, secant, and Newton-Raphson method. Most of researchers just using either one of these methods for their findings, but ours using these three methods and compare the result. By applying root finding method for these three methods, the least absolute error will be chosen as the best method for the final result.
For our problem statement, overflow will happen if the value of depth of water tank is incorrect and if the accurate overflow submerged ball cannot be obtained, it will cause a waste of water. Therefore, it is important to measure the accurate depth to avoid the overflow happen. That is why we must find a correct method to calculate the right level of the depth of water tank. Osmosis is a process where a weaker saline will tend to migrate to a strong saline solution. Therefore, we use reverse osmosis system to get the purifier water without any substance. The objectives of this study are: first, to formulate a polynomial equation using Archimedes' principle according to the radius of the ball submerged in the reverse osmosis water. Second, to estimate the depth of the submerged ball in a reverse osmosis water system using bisection method, Newton-Raphson method, and Seeker method. Third, to identify which method is suitable in the calculation of finding the root of cubic function equation. For the benefit and significance, this research will give accurate measurement of the depth in water tank. Therefore, this research can solve overflow problem and minimize the water consumption for daily use. This research will encourage the factory department, user household, and hospitality to be drawn to apply either bisection method, Newton-Raphson method, or secant method in calculating the depth of submerged ball in a reverse osmosis water system.
For scope and limitation, this study will concentrate on using the application of bisection method, Newton-Raphson method, Seeker method, and buoyancy force to find the depth of submerged ball in a reverse osmosis water. The absolute relative estimated error at the end of each iteration and the number of significant digits at least right at the end of each iteration can be discovered from the result. For the implementation of this study, applications such as buoyancy power, Archimedes theory, bisection method, Newton-Raphson method, and Seeker method will be used. Background theory of Archimedes' principle. According to Mohazab in 2017, the theory of Archimedes is one of the most important physical and fluid law mechanics. The density of an enormous object relative to the density of the fluid can be easily calculated without measuring any volumes.
For overview of reverse osmosis, Gernot 2017 stated that reverse osmosis was invented 60 years ago. It provides a valuable physical solution for marine desalination, wastewater contamination, and water treatment. Gernot also stated that treatment of wastewater may be used in irrigation as a drinking water supply and for production and other similar purposes in various industries. Multi-stage, flash distilled, and reverse osmosis processes are currently used to recover wastewater. Bisection method is the easiest method to find the root of a function. This method is based on the existence of a root in a specific interval. This interval is then halved or divided into two parts. The root is known to be lying in either one of these intervals. The iterative sequence is continued until a desired stopping iteration is reached. An application of bisection method from previous study. Muhammad Ali stated that a new modification of bisection method, namely fourth section and sixth section methods, are introduced. These methods are tested for several selected functions by using Maple software. The results are then analyzed based on the number of iterations and the CPU times or process time.
For the literature review on the Newton-Raphson method, the Newton process is termed the Newton-Raphson iteration attributed to Sir Isaac Newton and Joseph Raphson. As one of the most common root discovery techniques, the technique aims to find the equation fx to equal 0 where fx is a single variable function that stays constant and distinct. The Newton equation uses tangential lines for approximation. An application of Newton-Raphson from previous study, Gupta, stated that Newton-Raphson method is an iterative scheme used to solve nonlinear simultaneous equation with each iteration, its value also improves. No convergence does prevail. Just half of the correction was used to increase convergence. The literature review on the secant method, the measurement of derivative is a possible issue when applying the Newton process, although the evaluation of derivative of polynomials may not be a problem. Some function may be extremely difficult or repetitive to determine in derivative. We consider next a procedure that converges almost as easily as Newton's. This approach imitates Newton's method but prohibits derivative from being measured. An application of secant method from previous study, Babaji and Jonki 2013, stated secant method demanded two assessments of functions per iteration, but only one is a new analysis. The secant method is compatible with superlinear functions. There must be two initial approximations.
For stage 1, first identify the equation of Archimedes' principle. This application has been applied for root findings. The volume of the ball submerged under water given by this equation, where r is the radius of the ball, h is the height of the ball to which the ball is submerged. From calculus, where A is the cross-section area at a distance x from the center of the sphere. The lower limit of integration is x equals to r minus h, that is where the water line is. This figure shows that deriving the equation for volume of ball underwater and the upper limit is r, as that is the bottom of the sphere. From the figure above, for a location x, OB equals to x and OR equals to r, then form this equation. And AB is the radius of the area at x. So at the location B is this equation. So we form this equation. After substituting, we form this equation. After divide by density of water, we got this equation, where the specific gravity of the ball is given by this equation. Lastly, after substituting, we get to form this equation.
Stage 2, method selection and applying the method. Based on the three selected method, we apply all the method into each formula of the method, then repeat the calculation until desired iteration.
For the methodology in stage 3, we do comparison for final iteration between bisection method, Newton-Raphson method and secant method after done all the calculation. Finally, use absolute error to find difference between exact value and approximate value. Which error gives the smallest approximation will be the best method. Result for bisection method. Bisection method required 12 iterations. The approximate value for the bisection method is 0.0856. Result for Newton-Raphson method. Newton-Raphson method needed 6 iterations, where it is a quick way to find a good approximation for the root of the function. The approximate value for Newton-Raphson method is 0.0855.
From this table shows that secant method requires only 2 iterations to find the roots. The approximate value for this method is 0.0851. This table shows the calculation for absolute error where the exact value minus the approximate value, and we can see that Newton-Raphson method gives us 0 exact value.
In conclusion, this study is conducted to find the depth of submersible in the reverse osmosis water using the base method. Using bisection method, the result shows that the absolute error is second highest error compared to Newton-Raphson method absolute error. However, a second method is not suitable because it has shown that this method gives the highest absolute error. Finally, the base method is Newton-Raphson method.
For future studies, Newton method's convergence rate is rapid in comparison to other techniques. Thus, in contrast to other methods, the Newton technique has a rapid convergence rate. In conclusion, the recommendation is to use the suitable equation that will be applicable to all the numerical methods for a future study to make the calculation easier.
That's all from us. Thank you.